This video will give a demonstration for homework 1. Now let's go and look at question 1. So question 1, suppose that Bob would like to choose buy now, pay later option for online shopping. He can only afford to pay a fixed amount of $10 for next 15 months. And we now want to know what is the present value of these future cash flows. So we can simply use the present value function. So the discount rate here is 15%. 15% is the interest rate that Bob has to pay. Number of period is 15. And the payment will be here minus 10. Now here, this number is already a negative number, so I don't need to do anything here. And my present value here will be positive $58. So question 2, I will use the data table to graph the present value of a function of the discount rate. And I need to input interest rate from 0 to 20% and increase by 2% every time. So from 0 to 20. To do the data table, we always want to input the table header first. The header will be the present value here. So now we want Excel to calculate automatically for us to just change the discount rate here. So the initial discount value for discount rate for calculating $58 is this 15%. So now we want to use different discount rate here at a rate of 0%. What will be the present value of these future cash flow? At a rate of 2%, what's the present value? At a rate of 10%, what's the present value? So now we want Excel to do this all at once. So I go to data, what if analysis, data table. So here the input is the cell. So it's here the cell, the parameter that we are changing here in this column. And the parameter that we use for calculating the header is this 15%. So the input will be this cell B2. So we don't have any row input because we don't have, this is just a one-dimensional data table. We don't have any parameter that we are changing in a row. So we just leave row input cell blank and input the column input cell. Click OK. Okay, so let's just check. Okay, so when the discount rate increases, the present value decreases. So that means our result is correct. So now I just want to graph this relation. So I select these two series. I go to insert, recommended chart. I think a better chart to represent these relations properly would be the scatter plot. And usually we want to name the title. If you want to change the exit band, double click and choose exit options. Now I will just change it to 20%. If you want to change this, you can just click delete. Okay. So now we can go ahead to question 2. For question 2, we first need to produce the data table and make a graph for this function. Now we already have the formula for this function here. This is 3 times x squared, x is this cell B2, minus 2 times B times B2, B2 is this x here, minus 15. Now the data table header will be just this cell B3. So I'm just repeating the process of making the data table. So what is the x that we use to calculate 6? So this will be the cell here. Now I want to graph this function, insert. So now let's move on to question 2b. We want to use solver or goal seek to find two values of x for which fx equals to 0. So we want to find this point here and this point here. Now we know the y value of these 2 points is 0. So that's when fx equals to 0. So you cross this axis here. And however, we don't know the exact x value. We know that it is close, to minus 2 here, and it is close to 2 point, for example, 2.5 maybe here, but we don't know the exact number for x. So now we want to use two tools in Excel to search for this value or to calculate this value. So here, both of these tools will give you the same or very close result. So let me just first use solver. For using solver, like try and error methods, we need to have some initial value for Excel to start its searching. So let's define the point here as the first 0 and the point here as the second 0. Now the first 0 will be close to 2 to 4. So I'll just input here as the hint set here. I'll just input 5. And then I also want this equation, this formula. I copy, paste. So move this down. So some initial value here, this is 5, and Excel will start to search from 5 and then getting closer and closer to this point. For the second 0, Excel will start to search from -3 and getting closer to this point here. So now we want to start the process of using solver. So go to data, solver here. If you don't find solver here, so go to files, option, add-ins, Excel add-in, click go. Make sure you check the box here. Click OK. Now here it's like a calculator. It's like the financial calculator where you have some input and then Excel will output the result for us. So here our input is, I'll set our objective variable. Our objective variable here will be, we want fx equals to 0, right? So we just need to enter the fx, which is here, fx is this cell B27. We'll make it equals to 0. Further on, if you want to use solver to solve other questions, you can maximize this objective, you can minimize this objective, or you can make it equals to 2, 3, 4, any value. And you want to change the variables that we use to calculate this cell B27. So the variable that we use to calculate cell B27, the variable we want to change is this x. So then everything looks pretty good here. If further on there is any constraints that you want to add, for example, you want this x to be greater than 0, you can check this box. Here we don't have any constraint. So I click OK. So now Excel solved the problem. It is somewhere at 2.59 that fx will equals to 0. So now I do the same thing here for the next 0, so which is here, I want Excel to start searching from -3. Okay, my objective is now B31. Is this fx function here? So I want to force fx equals to 0 by changing x. I want Excel to solve for x. So for the second 0, we will have x equals to -1.9, which is somewhere close to this point, so that fx equals to 0. Now next, I want to show you using goal seek. So I will set everything to the original value, 5 here, -3 here, copy the formula, So go to data, what if analysis, goal seek. Now you may find out that this is very similar to solver. The only difference is that here we cannot add any constraint, but the top part is the same as solver. So we have some objective cell here and force the objective cell equals to some value, and then by changing some value. So here our objective here is this fx equals to 0 by changing x. Click OK. And now I do the second 0. So this completes question 2. Now we can move on to question 3. For question 3, suppose that a project has a growth rate of future cash flow equals to 10%. So there's growth rate here, 10%, discount rate here, 15%, and initial cost is 500. And in the future, year 1 cash flow is 100. So each year, the cash flow starting from year 1 equals to 100. Each of the following years, the cash flow will be grow at a growth rate equals to 10% here. Now that I want to calculate the NPV of this project and the IRR of the project. So the NPV, we first use the NPV function. The rate should be the discount rate. And the value here is all these future cash flows. So then I also, now this is just the future, this is just the present value of all these future cash flows from year 1 to 5. If I want to calculate the real NPV, I want to add the initial cost. So it's negative. That means that this project is not profitable. The manager should not go for this project. For IRR equals enter. We do not need to worry about unconventional future cash flows because these are all positive numbers. So now we can look at question B. Use two-dimensional data table to do a sensitivity analysis on NPV of the project. So varying the discount rate from 0, 3, 6 to 21, and varying the growth rate from 0, 3 to 12. So we already have all these things set up here. There are different discount rates and different growth rate. So now I just need to input the table header. That will be the NPV because the question here asks the sensitivity analysis on NPV. Now I select all of these, go to data, what if analysis, data table. Now be careful about the row input and column input here. So the column input, which is the discount rate, and the discount rate that we use for calculating this 101 will be here, cell B3. And the growth rate here should be cell B2. So here we are changing the growth rate, and the growth rate that we're using is 10% for calculating this NPV. Okay, so now we finished question 2. We can move on to question 4. For question 4, I think this is a very straightforward question. So I will simply give you the answer. So I'll leave the VBA coding part to you. I think that's pretty straightforward. If you have any question, you can reach out to me. But if your coding is correct, then that you should have -2 here, 1 here, and 6 here. Now I want you, of course, I don't want you to enter the value here, but instead I want you to use your user-defined function. For example, my function, I call it exercise 3, and then start input this one. Okay, so I leave this part to you, and we can move on to question 5. For question 5, actually, here we're asking to write a user-defined function so that it will give us the return. So the return is calculated by the price at price P0 at time 0, so T minus 1, and with the price at time T1. So here we have P0 and P1. To calculate the compounded return, in another word, that will be the log return. Simply, we'll take the log of the ratio of P1 divided by P0. So we need to use this, we'll have to call the log function in Excel. So Excel has a pre-built log function. Okay, this will return the natural log of a number. So this is Excel's function. If we want to use this function in VBA, we need to call worksheet function.ln. Or VBA has its own log function that will be this log. Okay, so now I want to go to my VBA. I'll write some comments here. Now I don't want to write from scratch. I want to just copy some of those previous code. So I'll just copy this one here. I'll name this log return. P0 and P1. So log return equals. Now let me just use the first method. and I want to make sure that I know how to use the Excel function of taking the log. Should be just a number. Okay, good. It should be just a number. So just go ahead and do this. P1 divided by P0. Okay, now I go back. Log return. Now the input here, the first input should be price 0. Okay, the previous price. Okay, that's using the method 1. If I want to use the method 2, I'll name this M2, method 2. I can just call the log function in Excel. Okay, I go back. Equals log return method 2. Okay, there's an error here. M2. Okay, so 2 function here should give you the same result. Okay, one is calling the Excel log function, taking the natural log. Another one is to use VBA log function. So now we can go to question 6. Now let's start question 6. So first, spend some time read the question. The goal here is to calculate the payback period and define a function to calculate the payback period. So then how to calculate the payback period? This is a concept that we learned in previous class in the financial management class. So to calculate payback periods, basically it is, to calculate the time required for the return on an investment to repay the sum of original investment. In this case, let's use the example in Excel file to demonstrate that. So initially we need minus $1,500. So that's our original investment. And then in year 1, we start to accumulate some cash inflows. So I add the cash flows of year 1. So it can pay back $400, but we still have a negative 1,100 remaining. So for I just start to accumulate my cash flows, and then I would just add my year 2 cash flows, which is 600. Now my initial original investments drop to, the amounts that I need future cash flow to repay drops to minus 500. And finally, if I include the 3rd year, then it will turn positive. So that means in this case, if I want to have a whole year solution, so the number will be at the 3rd year, I can repay all the sum of the original investment. So here should be 3 for this case. And then for this question here, so initially I have minus 4,000. So that's the amounts that needs to be repaid in the current year. So then starting from year 1, I get this $400. So this amount will drop to minus 3,600. So then I keep going and adding more future cash flows. It turns out to be minus 3,000. And I add more, drop to minus 2,400, and then add the final cash flows here. In this case, it's still minus 2,100. That means we don't have a payback time for this case. Okay, we have no payback in this case. So this payback equals to 3. So now I believe you get the idea of calculating payback. It's just how to implement it in Excel VBA to write a function, ask Excel to calculate this automatically. So we need to use the for loop statement to define this function. And we name the function name payback. Input is R and N. And R here is actually an array from cash flow 0 to cash flow 4, which is from here to here, including the initial year. So we have 5 different cells here. And N here is the number of periods. So the number of period is 5 in this case. We have period 0, 1, 2, 3, 4. Okay, we're including the initial period here. So then, if you remember, there is similar for loop statement in the example in the lecture slides. So my habit is always, if I can find some sample, I'll go back to the sample codes. So here is the sample codes, the codes that I use to demonstrate for utilizing or calling the Excel arrays in VBA. Basically, we have this, we have input different cells as an array. And the way of calling all of those cells is bracket and I. And I, in this case, Excel will read it from row to row. So 1, this is R1, R2, R3, R4, R5, R6, 7, 8, and 9. So here is how Excel calculates this. So for I equals to 1, we're using R1, which is 3 plus S. And initial S is 0, so that will be just 3. When I equals to 2, we'll have S, which is 3 plus R2. And R2 in this case is equals to 4. So 3 plus 4 is 7. So that is the new S. And then we go for I equals to 3. So adding 5 to this S. So that is 5 plus 4 plus 3. So this is the idea of this loop. So I'll just utilize this idea, copy, and go to the Excel VBA. So I first need to change the name. R is still the array, nothing needs to be changed, and it's still the integer. So I define S, define I. That is okay. So in this case, it's relatively simple. So even you drop this 2 line, it's not gonna have any effects. There's no ambiguity here. So then we want to start from S equals to 0, and then adding more and more cells later on in this case. So don't need to change anything here. So starting from I equals to 1 to n. So I equals to 1 to n here. So we want to add each of these numbers together, but in this case, we want to stop at some point. So now let's first work on how to add all those things together. So that is exactly this line here. Okay, I would just maybe change it to this. So we want Excel to have a stop, to have a condition, okay, where we want Excel to stop this loop if S is greater or equals to 0, then exit. Or after exiting 4, we want to assign a value. Now here, since our period here representing the starting point is 0, so actually the output here should be I minus 1. This is because this is I equals to 1, the first loop, I equals to 2, I equals to 3, I equals to 4. So therefore, to output the payback, the correct number for payback, that will be I minus 1. So now this works perfect if there is a payback period. However, in the second case, there's no payback period. So therefore, Excel will only report n minus 1, which will be always 5 minus 1, that is 4. And in this case, actually, there's no payback period. So we want to have a final statement here just to compare, just to make sure that we have a valid payback period. So if S greater or equals to 0, then output the payback. If it's false, okay, and now I can go back and check my function. Payback is here. And the number here is 5. Okay, so there is an error here. Reminds me I don't have an end if here. So I will add end if. Equals to 3, that is correct. And next, payback 5 equals to no payback, that is also correct. So then that completes this question, but I want to further illustrate to you how does this loop works here. Now let's read this code here. So we first define S, define I, and then S initial value equals to 0. And then we start the loop from here to here. until s is greater or equals to 0, then exit the loop. So we can just go ahead and look at how it works. So when I equals to 1, equals to 2, 3. So then we execute the next line. So s here equals to initial value is 0 plus R1. So I here equals to 1, so plus R1. R1 is this cell here, B3. Okay, so this is R1, this is R2, R3, R4, and R5. So we're only adding R1 here. So that is minus 1,500. That equals to minus 1,500. So the next line will be to determine if s is greater or equal to 0. S in this case is minus 1,500. So the answer is no. Okay, so then since it's no, so we will not exit. So we'll go to next I. So go to next I. So s equals to minus 1,500 plus 400 equals to minus. Is s greater or equals to 0? Still, the answer is no. It's still a negative number here. So then I go to next loop. So when I equals to 3, s equals to plus R3. R3 is, this is R1, R2, R3. So it's 600 equals to 5 minus $500. Is this greater than 0? The answer is still no. So now I go to the fourth I, s equals to minus 500 plus R4, 1, 2, 3, 4, that is 600. So this equals to $100. So minus 500 plus 600 equals to positive 100. And then we look at this, if s is equals or greater than 0, in this case, the answer is yes. So since it's yes, it's satisfying this condition, then we will exit this loop. So we will exit this loop and start to execute the line here. And then start to execute the line here. The question here is whether s is greater or equals to 0. The answer is yes. So then payback here will be equals to I minus 1, and that is 4 minus 1 equals to 3. So finally, payback equals to 3. So which is how we get to this number here, 3. So it is exactly the payback period for this future cash flow. And then for the second case, we will have s, which is less, it's a negative number for adding all of those future cash flows. So this loop will stop when I equals to n, so when I equals to 5, and then it will start to execute the next line here. So for the next line, if s is greater or equals to 0, the answer is no, so it will start to execute this line here. So then output payback equals to no payback. So that's why we got no payback here. Now I can start to write my homework in Word. So this is homework 1 and my name, and I can start question 1. How much can Bob spend now for online shopping? And I got this number here. And then question 2, use data table to graph. So I just need to attach the graph. So 2. And remember, there's a question here. Describe the relation, how sensitive it is. So I hope you can write this here. Start to provide some of your answer for the question here. Okay, I think this is A. So for question 2, again, I attach the graph. Okay, so this is just an example. Okay, you can basically have your own way of presenting your results.